Hi, welcome to this session. Today we're going to talk about blockchain. These are the topics which we are going to cover today. What is blockchain? What is mining? What is Bitcoin? What is a reward? What is wallet? What is Ethereum? What is ERC20 token? And what is smart contract? If we talk about blockchain in a layman language, blockchain is just a database which stores transaction in a encrypted format. So blockchain is a immutable database. Once a thing that is entered into a blockchain, once a data is entered into a blockchain, it cannot be updated or deleted. So it's a single entry point. So let us go to the next slide. So let us go to a brief history uh, that how databases were stored. Earlier, earlier databases were stored into a file system. Like we can see there are 4 computers, and every computer maintains their own file system to store the data. Maybe it is any kind of file format. And when they have to sync upon, there were major challenges if they have to sync the data at the end of the day. There were major challenging, and there were lots of errors happening. So that's the main problem. To overcome this problem, RDBMS and DBMS concepts came into the picture, like SQL Server, Oracle, MySQL, and many other databases were there. And now, to solve this problem, there was a central server, a single entry point for all these machines. They can connect to this server and can share their data. So if this machine make any changes to data, uh, so it is accessible to this machine as well, to this machine as well, and to this machine as well. So central server has stored the synchronization problem of data, but there was a one drawback, that all these PCs were connected. All these PCs or clients were connected to this single set of computer or server. So in future, if the server crashes sometimes, so all these systems will be affected. And another problem was that there was a single entity whom they have to trust to store their data. If in anyhow they have to trust on this party as well, which was maintaining their data. Then let us go to next slide. In this slide, after this concept, the decentralized environment came into the picture, where the data was stored in multiple servers. Like in this example, there are 4 servers, and all other clients, they are communicating to these four servers. If in future the server goes down, these 3 server shares the responsibility. So in this way, data was more secure. But this still have to be keep a trust on these 4 entities only. Then blockchain, it comes into the new concept, that is decentralized distributed system, where every client maintains their own copy of data. For example, there are 4 nodes. Uh, this is one node, this is second node, this is third node. We'll take the example of these 4 nodes, and this node maintains the same copy of data as this node, and all the 4 nodes have same copy of data. If its data is changed into this node, it will broadcast to this node, and this node will broadcast to this node, and this node will broadcast to another node, another connected node. So at the end of the day, at the end of the transaction, all these nodes will maintain the same copy of data. So in this way, uh, every nodes has their own copy, and it serves a trustless environment. Like if there are some if there are some entities, they can't trust on each other, then blockchain is the best way, because everyone maintains their own copy of data. If anybody changes their own data, so all the changes will be reflect to all the servers. So that is how blockchain maintains the data. Okay, so okay, let us go to the next slide. This is how it is displayed. This is a centralized server, and this is the decentralized, and this is a distributed decentralized, where how the where blockchain is maintaining the data. Now, how blockchain works. Okay. Before going to this slide, let me share something with you on the whiteboard. I'm just moving to the whiteboard section. Okay. Here I want to give you a brief idea that how blockchain work. So as I told you, there are nodes. So a node is nothing. It's a computer. Like there are four nodes. If we see there are four nodes, it means there are four computers which are connected to each other. Uh, you can So if this node makes any transaction in this data, or if any user makes any transaction, then all the three nodes has to validate the data. So once all the three nodes will validate the data, only that transaction will be mined. So let me draw it again. Like there are four nodes, and they maintain the same copy of the data. Whatever data is in this node 1, same set of data in node 2, same set of data in node 3, and same set of data in node 4. So if this node makes any change in its ledger or make any transaction, then all the three nodes has to validate that transaction. Once the transaction will be validated, then that transaction will be mined or saved. No, so that's how it works. That's why we can say in trustless environment, a blockchain comes into the picture. So now, what is a block, right? So a block is a set of transaction. You can say this is a block, and it has certain set of transactions. And block has two parts. One is header, and one is metadata. So every block is connected. Every transaction happens in a block. So there is a chain of block. That's why it's called blockchain. So this is a chain of block. So how these blocks are connected? Let us suppose this is our block one. It has some header information and there is some metadata. Now when block two will be mined, what it will do? It will contain get all the information including this header and the metadata, and create a hash of that information. And just like say it will take all the information of block one, it will crush that information in a layman language. It will crush that information and save it into the header. So here is the block one information, and then it will store its own information. Whatever transaction is there, it will store it here. Now when block two will mine, so I'm sorry, when another block another block will be mined, it will do the same thing like block 3. It will maintain information, all the information of block 2. It will crush the information of block 2, or you can say it will create the hash of information of block 2 stored in its header here, and then its own information. Similarly, block 4, it will store all the information of block 3 and it on information. That's why it's impossible to hack the blockchain. For example, if somebody comes and it makes a transaction it sorry, it modifies this block and tries to make something illegal or unethical, then all the other blocks will check their header information. And obviously if it makes a transaction like it modifies this transaction, but then it has to modify this block as well, because this block contains the information of this block, and it has to modify the past blocks as well. And that thing has to do so fast, because there are lots of blocks, and it will take lots of time. In the meanwhile, this transaction cannot be validated, because it will take lots of time. It needs a quantum computer to hack the blockchain, right? So that is what I explained, how blockchain work, what are the headers, and what is the blockchain. Let us go back to the slide again. In this slide, that's what they are trying to explain. Here how a transaction comes into the picture. When once a transaction is created, other nodes validate that transaction. When the transaction has been validated, then that node is mined, and its is reward is given to the miner. So what is a reward? Like I told you that once a transaction is happened, all nodes, they have to validate the transaction, and which nodes do this validation earlier or faster, that nodes got a reward. And this reward is definitely in terms of Bitcoin. If we are into a Bitcoin blockchain, and if we are into Ethereum blockchain, then it is in terms of Ethereum. That is also called a gas fees. So that is what is happening. And what is the validation? It is called a puzzle. Like they have to validate the headers. So once a transaction it comes, so it needs a superpower computer that validate the transaction, that this transaction is ethical or not. And they have to solve the puzzle. They have to calculate all the headers. They have to calculate the next header block, everything. And whoever calculates that first, uh, that gets the reward. I'm sorry. So in this slide, it's same thing, that how blocks has been saved. So so here it is block one. Here it is block one, and it is the header of the block, and it it is saved here, and its information is saved here. So that is how all the blocks are interconnected. So what is Bitcoin? Bitcoin is you can say it's another use case of blockchain that is built upon the blockchain. It's the first use case of blockchain. Uh, so Bitcoin is mainly used for the money transactions. So all the virtual money has been transacted with Bitcoin. So Bitcoin was founded in 2008 by Satoshi Nakamoto, and currently I guess it has a lots of value. It is around $57,000 to $60,000 in between, and the supply of Bitcoin is limited. That is was 21 million something, and that's why they are very much in demand. So once the supply will be ended, so it will get into the more price. So here it is explained what is Bitcoin mining. So it's the same concept which we talked earlier. If anybody want to send a Bitcoin to somebody, like here you can see the Alice want to buy a Alice want to send a Bitcoin to Bob, and then it has so Bitcoin has a one two thing. First, to make a transaction in Bitcoin, you have to create a wallet that is called a public wallet, and this wallet has a key. This is called the address, a public key. And whenever you want to receive a Bitcoin, you just have to share that public key with anybody, and that person will just do a transaction to your public key. That is also called a wallet, and then Bitcoin can come to your wallet. To send the transaction, if you want to send the transaction to anybody, you need a private key as well, like you like there is mailbox on the door, right? So mailbox, so you can see mailbox, it has one public key and a private key. In the public key is accessible to anybody, where anybody can come and throw the mails in your mailbox. And the private key is there where that is only with you, where you can open that private key and gets the mail back. So similar, same is the concept with the blockchain. So one is the public key. Public key is the address of your wallet that you share with others, and they can just send the blockchain to you. And private key is with you. Whoever has the private key, they can use that bitcoins. And to send the bitcoins or to withdraw the bitcoins, you have to use the private key. So that's we have covered the concept of wallet, public key, and private key. So wallet is just address where you save all your bitcoins, and to use the bitcoin, you must need a private key. The the problem with bitcoins was its transaction fees was too high, and the transaction time was also too high. If you send a transaction of bitcoin, it around take 20 to 30 minutes uh, to get that transaction minted or mining. To overcome these all issues, Ethereum was invented in 2015 by Vitalik. Uh, Ethereum has various features, like Bitcoin was just used for money transactions, but in Ethereum we can create our own tokens, we can create our own coins, and we can do lots of programming in Ethereum as well. And as compared to that, Ethereum transaction fees is less, and Ethereum minting time is also less. So we can see the difference between Ethereum and Bitcoin. Okay, there are some key points. Bitcoin is signi- signaled an emergence of. Okay, let us go something better. So the major differences is mean the transaction fees is very less, and transaction time is very less. Here, the Bitcoin, the block time is 10 minutes, and but in Ethereum it's 12 to 14 seconds. But earlier it was in Bitcoin it was 30 minutes. Maybe they have made some hard fork and something. So now it's reduced to 10 minutes, and this is just 12 to 14 seconds. That are the major differences in Ethereum and Bitcoin. And another thing, Ethereum is programmable. You can do lots of programming in Ethereum that will discuss further. So, like I said, we can do lots of programming in Ethereum. So we can do programming with the help of smart contracts. What are the smart contracts? So let us go to the whiteboard to understand a smart contract. Smart contract concept was introduced in Ethereum. So smart contract is just a executable piece of code which runs inside the blockchain. That's the simple definition of smart contract. So smart contract, if you can see, it is combination of two words, contract and smart. So it's a contract which is smart. So let me explain how. Let us take an example of a rent deed, right? So everybody who takes a house on rent, they have to sign a rent agreement, and there are lots of terms and condition has been made in rent agreement, like you have to give advance to a owner, like for example you have to give advance 10K to the owner, and then he will refund it when you give a 1 month notice. And another example, for every fifth of every month you have to pay rent, that is around you can say 15K. And after, if you got late, then after every 7 days you have to pay a fine of 1% as a late fees. So all these are three examples of rent deed. What happens, like if you have given the advance to the owner, sometimes owner doesn't give it back to you, and sometimes you get late from the rent, and but you don't pay the fees. So all these things get automated with the help of smart contract, where we can write a smart contract. Smart contract is written in a language Solidity. Solidity is a programming language to write the smart contracts in Ethereum. So we can write a smart contract where we can write a code where let us say A is the owner and B is the tenant, where A gives some amount to A that will be skewed in the blockchain. It will go to the it will skewed in the blockchain in a smart contract, and then B has to skew the rent of 15K into the blockchain, and if it which will be automatically paid on 5th of every month. And if B does not skew that on 5th of every month, then there is a rule that after subsequent time, the percentage of late fees will be deducted. So all these logics we can write in the smart contracts. The benefit of writing in the smart contract is that they are executed in blockchain, and I already told blockchain is immutable, where if any code is written, you cannot update or delete that code. So people can trust the smart contracts. Like if P has put some money in smart contract, then and in a smart contract a logic has been written that if B has put a money in a smart contract, and then without the consent of A and B both, that money cannot be withdrawn. So that can be written in the smart contract, so their money will be safe. So if A and B both want to withdraw the money, then that can be withdrawn. So they have to sign that contract with their private key. A will sign it with our private key, and B will sign it with on private key, and then they can withdraw the money. So there can be a multiple set of transactions which we can do in smart contract. That's all about the smart contract. Let us go to the slide. So here, what is it in the smart contracts? Let us read it. Okay, so that's what I'm saying. It's a contract that is written on the blockchain. Just a moment. Yeah. So here, what is saying? It's a set of code which is written on the blockchain, and contract is a part of public blockchain. So no, it's not necessary. Means there are types of blockchain. Contract can be written in a private blockchain, in a public blockchain, in a Ethereum, sorry, in a consortium blockchain. So it can be written anywhere. And there are two parties are involved in the smart contract. So these parties need not to disclose their name. They just have to give their public keys, and with these public keys, the logic has been written on this public key. Like if this like A has a public key and B has a public key. If A and B both agrees on to some condition, only then this transaction can happen. So that's what it written over there. So contract executes itself when a condition is met. That's true. And regulators are use blockchain to keep an eye on the contract. Yeah. So just like when there is an agreement, once there is a complex agreement, like we go to a job or we sign any agreement with for our business owners or anything, then these language are very much legal, and a common man for a common man it's difficult to understand. So same is the thing with smart contract. Like I sign a smart contract with you where I'll say, okay, if you will give me 100 likes, then I'll give you few tokens. And that part I told you, okay, I made a smart contract on that, and that smart contract is deployed in blockchain. Now you, how you will trust me, that what logic there is there in, because if you are not a programmer, then you can't trust me. What is the logic written in the smart contract? For that, there are the smart contract auditors, and the smart contract is sorry, there was some call I'm lost. uh, yeah, so there are smart contract auditors where you can hire them. They can read the smart contract line by line, and they will tell you if there is something wrong in the smart contract, or if smart contract is really what you are really agreed upon. So they various lots of testing on that, and they read that. So that's what it has been written here. So now next interesting part, ERC20 token. I'm sorry. So what is ERC20 token? So ERC20 token is also a smart contract. Like I told you that smart contract is nothing. It's just a executable piece of code where there are different set of instructions which can be executed on specific period of time. So that is what is ERC20 token. So ERC20 token is a smart contract where you have written some set of instructions, like you can say it's a cryptocurrency that you have built in the Ethereum. Like you can make the token with your own name, like ABCXYZ. Any person can create their own tokens. Just they have to make some gas fees, and like I can create a token with the name of Amit, and with certain set of instructions where I will say, okay, what should be the number of the tokens, how many tokens I want to create. So there is a smart contract. In smart contract, I given the number of tokens, that is 10,000. Then I given uh, expiry date of smart contracts. So we can make two kind of smart contracts. One that got automatically expired at certain date of time, and right. So or another that goes for the lifetime. And we can say our smart contract is mintable or not. Mintable means like when all my 10,000 tokens will be exhausted, then I can mint new tokens or not. And then I create a mint function, and then I create a send function, like if I want to send that smart contracts to anybody. And then I also create multiple set of instructions over there. Like in send token, I can make an instruction. If I am sending more than 10 tokens, then my transaction should be failed. So these are the multiple set of instructions which I can write in a smart contract. And a smart contract which has these certain set of properties is called a ERC20 token. So these are the set of properties: total supply, that is what I told, total supply is number of tokens, that how many supplies I want to create for my token. Like it has a 50,000 unit, it's a 1 lakh unit. So let us say it's a 50k units. Now also for Amit token, like if I create a token Amit, so it has 50 distributions. Then this is the transfer method where I can send the tokens to anybody with this transfer method, where I have to give the address of a public owner, or sorry, public key of any other Ethereum owner wallet. So I can send the token to that by signing with my private key. And then there is another method, balance of, and there is one another method, transfer from, and approve, and alliance. So these are the certain set of methods when our ERC20 token meets this certain set of, when our smart contract meets this certain set of methods, it is called a ERC20 token. So we can deeply go detail it for each set of method. One will learn the coding of smart contracts. So that was all about me. I'm not sure if I have discussed about the types of blockchain or not. So if okay, I'll take another 2 minutes, and I'm not sure if I discussed because I missed that slide. So let me share the whiteboard again where I can tell you the types of blockchain. So like BCT stands for blockchain technology. So what are different types of blockchain? As I told you, what is blockchain, and there are different use cases of blockchain, like like Ethereum, Bitcoin, Stellar, Ripple. So there are many use cases, or you can say many blockchain is there. But what are the types? So one is a public blockchain, one is private blockchain, and one is consortium blockchain. If we will talk about public blockchain, Ethereum is a public blockchain. In public blockchain, what happens, anyone can see the transactions. You can go to the public ledger of blockchain. Let me show you. uh, so in public blockchain, what happens, anyone can see all the transactions, and uh, it's a very transparent. Like if you want to see the token, like if want to see a token like mm, 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 native token. Okay, some problem. Yeah, there is one native native coin. If I want to see this native coin, so you can see this native coin is here, and these are all the set of transactions, and this is the total supply of native coin, and this is the decimal values, that how many decimal values, how many float values we want to store, and this is the transactions, that to whom it has been sent, how many quantities has been sent, and you can search any token and see any transactions over there. So that's the beauty of public blockchain. So everything is transparent, and anyone can become a part of public blockchain. I mean to say, can be a node of public blockchain. Anyone can be a node for that public blockchain. uh, it means you can mint the transaction, you can validate the transaction, but you have to have that a superpower computer with some sort of GPU computation power, so that you can mint them. Otherwise, with a normal computer, it will heat up and it can crash your system. And then, what is private blockchain? In private blockchain, what happens, like there's some set of companies, or there is a company which has multiple branches. They want to create their own blockchain, which they don't want to I'm sorry, just what excuse excuse me, guys. So what happens in private blockchain? In private blockchain, there are some sort of companies, they don't want their data that should go beyond their premises, but they want to implement the blockchain, so they can create their own blockchain. There are certain private blockchain frameworks available. You can even fork the Ethereum and create your own private blockchain for your own set of company. So this blockchain will work with multiple nodes, but that will work with their own set of companies. And there is one consortium blockchain. Consortium blockchain is a combination of public and private blockchain. Like there are some companies, for example, there is company 1, company 2, and company 3. They are doing some kind of business, and they want all the transactions should be among three of them, so they can build their own blockchain which will be accessible for these three companies only. So that is a consortium blockchain. So that's all about the types and basic things of blockchain. Hope you guys have liked this lecture, and thank you very much. And one disclaimer, that all the materials and the images that I have taken from the net, so all credit goes to the real owners or content creators. So thank you very much. Hope you enjoyed this.